In order to determine the size of an interval, we're simply going to count the amount of steps. So say we start at C and we're going up to E. We're going to count from C, D, E. That's going to be 3, so we know we're dealing with a third. Sometimes we run into intervals that are called compound. This means that the interval is spanning over the distance of an octave. These can, however, be simplified into their simple intervals, so like a third, a fourth, a fifth, etc., and be referred to as a third, a fourth, or a fifth. You do not have to refer to them as a 12th, but it's important to understand that once you go above the octave, it still counts as an interval, and it's still going to be the same type of interval. It just spans over a bigger distance. The interval quality, however, changes depending on how many half steps we use to achieve that. Here's a chart right up here showing exactly how many semitones are in each type of interval. So going from C to E, we're going to count from C to C sharp to D sharp, and then up to E. Now, if we reference our chart, which some people have different ways of memorizing this, sometimes you can just memorize the semitones in the chart, but we know that's 4 semitones, which means that is going to be a major third. Now, if we were to subtract a semitone from that, we would get to a minor third. If we were subtracting another semitone, we would get to diminished third. And now going back to our major, if we were to add a semitone, we would get to augmented. Here are some examples of that. Major third, minor third, diminished third, and then we have augmented third. Enharmonic intervals are 2 intervals that make the exact same sound but are referred to differently. So taking a major third, for instance, here's an example of a major third, and then you're going to take a diminished fourth, which is the exact same thing, and here's the sound. So why does this work? Because it's the same amount of semitones.